Okay, let's do some math for fun. Here we are going to count how many rectangles do we have right here. And this is meant to be a 8 by 8, like a chessboard or like a checkerboard, okay? And keep in mind, this is meant to be a square, and each square is a rectangle. So by just looking at this picture here, we have a total of 8 times 8, namely 64 little squares, so that's 64 little rectangles. But remember, this right here, it's also a rectangle. So it's one whole row like this. It's of course not a rectangle, right? So the question is, how many rectangles do we have right here? As always, please pause the video and try this first. Okay, the answer to this, and let me just write it down right here, is we have a total of 1,296 rectangles. No more, no less. This is it. And if you just count, right, just seriously just count how many rectangles there are, I think you might be still counting right now, right? Maybe after I finish the video in like 10 minutes or so, you're still counting, but you know. We are going to see if there's any efficient way to figure this out rather than just count. Here is the first strategy, all right? The first strategy is that I think in the computer science, they just call this divide and conquer. Maybe it's like this. But in math, one of the problem-solving strategies is that when you are dealing with something hard, let's consider something that's easier, something that's much more doable. Consider the smaller cases. So let's see, what if we just have 1 by 1? Of course, you can just count this easily. We have one rectangle right here, right? And now, what if we have a 2 by 2 situation? So you consider some smaller situations, and hopefully, maybe there's like an answer, like there's a pattern for the answer that you can figure out. If that's the case, that would be so wonderful, isn't it? And let's see. Let's just count. This is going to be 1, 2, 3, 4. And then 1, 2, 3, 4. So total of 8, right? 4 of the little ones, and then 4 of the the longer ones like this. So now I have 8. And keep in mind, we also have the one big one, so we have a total of 9 of them, right? And now we'll just see. Let's see if we can do the 3 by 3 situation. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so we can just remember that this is set of 9 for now, and then let's do the 2 by 1s. So I'll just say this: 1, 2, 3, 4, 5, 6, and then let's do this way: 7, 8, 9, 11. 10, 11, 12. Right, so we put down plus 12, and now let's do the 3 by 1. 1, 2, 3, 4, 5, 6, right? And now let's do the 2 by 2, yeah? So this is 1, 2, 3, 4. So that's the 2 by 2. And now let's do the 3 by 2. 3 by 2 we have 1, 2, 3, 4. So yeah. So we did the 3 by 2. We did a 3 by 1. Now the last one is just 3 by 3. So the last one is just this, so plus 1. And of course, we can just add this up real quick. And if you add them up, this is 10. This is another 10, that's 20. So we have 32 and then 36. So based on the first 3 cases, we have 1 rectangle, 9 rectangles, and then 36 rectangles. Okay? All right, let's see if there's any pattern for this. How can we go from 1 to 9? Well, that's plus 8, right? And how can we go from 9 to 36? That's plus 27. And do we recognize these numbers? We should, because this right here is precisely 2 to the 3rd power. It's a perfect cube. This right here is precisely 3 to the 3rd power, right? That's also a perfect cube. So you can imagine how, what number do we need to add next? Well, we must add 4 to the 3rd power, huh? It seems like it. And 4 to the 3rd power is going to be 64. 36 plus 64, we get 100. And that's going to be the number of rectangles in a 4x4 situation. And I'm going to leave you guys to verify this on your own, right? Because 100, I'm not going to show you guys how to count up to 100. All right, so this is kind of cool. And the next one, we can just go ahead and do plus 5 to the third power, and so on, so on, so on. I do want to make a remark before we continue anything else. This right here, it seems legitimate, but it's still not perfect in the sense that we don't have a proof for it. Sometimes you cannot really judge the numbers, the pattern, based on the first few cases. Sometimes the pattern may be broken later on. That's why we have the mathematical induction, all right? But at the moment, just trust me that this is actually the correct pattern, right? So anyway, this is the 4x4 situation. Let me just write this down for you guys real quick, all right? So this is the nice situation. And of course, dot, dot, dot. And we are going to get to the 8x8 situation. And of course, you can just draw the rectangle 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It's smaller, but And you just pretty much do the following. So I wanted to know what this is. Well, the next one is going to be plus 5 to the third power, right? So once we get to the 8x8 situation, this right here, it should be 1 to the third power because that's 1, right? And then every time you just do 2 to the third power, 3 to the third power, and so on. So you do 1 to the third power plus 2 to the third power plus 3 to the third power plus dot, 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 up to 8 to the third power. And by now, if you have a calculator, you can just type this onto the calculator, and you'll see the answer is 1296. And now some of you guys might be mad at me because I'm still counting, right? So that's not efficient at all. Don't worry, I'm going to help you. I'm going to make this so cool for you, okay? Look at, this is 1, which is the same as 1 square. Oops, sorry, wrong color. 1 square. And if you look at 9, this is 3 square. If you look at 36, this is 6 square. And if you look at 100, this is 10 square. And look at 1, 3, 6, 10. Can we figure out the pattern for the next one? If you just look at the base, from 1 to 3 is you add 2. From 3 to 6, we add 3. From 6 to 10, we add 4. And you can imagine the next one is just that we add 5, and so on, right? So in fact, here, once we have the 8x8 situation, we could have done the following. This right here, it's the same as saying, let me just write this down again. The 10 square is the same as saying 1 plus 2 plus 3 plus 4 square, right? For the 8x8 situation, this right here, it's the same as 1 plus 2 plus 3 plus 4 plus 5 plus dot, 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 up to 8. And then you square that. And now I just showed you guys a really cool formula. When you want to find the sum of the cubes, in fact, you need to know the sum of the first natural numbers, and then you just square the result. That's all. So the idea is that this is counting how many rectangles that we have. So is this. They must be equal, right? Here's a really nice bonus. It's like the icing on the cake. Let me write this down. When we have 1 to the third power plus 2 to the third power plus dot, 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 plus n to the third power, this right here, it's equal to 1 plus 2 plus 3 plus 4 plus dot, 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 plus n, and then you square the result. And didn't we do this already with 5 different ways? Yes, we did. So all this right here, you can watch my other video for it if you haven't. It's equal to n times n plus 1 over 2, and then to the second power. So this is a nice way to argue that, how to find the sum of the first n cubes. Okay, as I said, this is still not the best way to do this. Now let's do some combinatoric, which is like one of the best in the world, all right? Now, go back to the big picture. Let's do the big thing right now, all right? We're all adults now, so we can handle this. We don't need to look at the small cases, right? Let me show you how to do it. Okay, what makes a rectangle rectangle? Of course, we must have two sides, and two sides on the top, and one side on the top, one side on the bottom, and then two sides, right? One on the side, one on the other. Let's say if I pick this rectangle from this board, which is a 3x2 situation, it has four sides, of course. And remember, as I said, we have one side here on the top, one side right here on the bottom. But you see, right here on the side, how many lines, how many horizontal lines do we have? You can just, well, 9 lines, but I will label it for you. 1 horizontal line, 2, 3, 4, 5, 6, 7, 8, 9. So you see, if you want to select this as your rectangle, what we did is we chose line number 5 for the side to be on the top, and then line number 7 for the side to be on the bottom, right? And how many ways can we choose 2 lines out of a total of 9? That's precisely 9 choose 2, isn't it? Right? 9 choose 2 tells you the number of ways that we can choose 2 things out of a total of 9 things, right? So that's good. And now, how can we select these 2 sides? Well, same argument. Right here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 lines as well. We just chose line number 4 to be the side on the left, and then line number 7 to be the side to be on the right. And guess what? Yes, we still have the 9 choose 2. So let me do this actually. My color was actually not matching. This right here is 9 choose 2, right? For the top and bottom. And then we multiply by 9 choose 2 for the left and right. So in another word, this right here is nothing but just 9 choose 2 square. So I'll write this down for you guys. This is just 9 choose 2, and then we square that. And 9 choose 2, if you would like, you can do it like this. Just put on 9, multiply by the next number, which is 8, and you stop. You just need 2 terms because you have the 2. Now it's a division. This was not division, okay? There's no fraction part here, okay? On the bottom, you just divide by this factorial, namely 2 times 1. And you can work this out now. 9 times 8 is 72. Divided by 2 is 36. So you have 36 square, and you end up with 1,296, right? And yes, this right here, I also showed you that 1 plus 2 plus 3 plus ... plus n, it's precisely equal to n plus 1 choose 2. Same exact argument. You can watch my previous video for detailed argument though. But this right here is a number of ways to choose the number of sides. Well, you know, hopefully you guys have seen my video, so yeah. This is another way to add 1 plus 2 plus 3 plus up to n, so which is this. But anyway, this is the quickest solution if you think with combinatoric, right? That's what I like the most. Anyway, some discrete mathematics for you guys. Hopefully you guys like this video, and yeah. If you guys are new to my channel, please subscribe. I would like to have you here. As always, that's it.